Okay, so let's take a look at another related rate question, which is a kind of a fun question. So let's read. A hot air balloon full of seniors skipping school start rising from a ground of the stadium 140 feet per minute. So start rising. This is helping you to understand that this is, dy dt is rising. It's going up, so 140 feet per minute. Okay, so let's look at this picture. Seniors rising, and this is Mrs. Working, our principal. Few years ago we had, so I'm forgetting to change this problem. I keep as it is, that way I remember her. 500 feet away. Mrs. Working standing 500 feet away from the liftoff. When the balloon is 500 feet above the ground, so you should not be substituting this first. This is just the rise when balloon was 500 feet above the ground. So assumption is balloon is rising straight up at 90 degree. Let's read further. Find the rate at which Mrs. Working's actual distance from the balloon is changing. Actual distance is the z, y, and let's keep it x. So obviously the relationship here we are looking at is x square plus y square is equal to z square. All three of them are changing, or which one is changing? Make sure that Mrs. Working is not moving anywhere. She's fixed. So x is a fix. 500 is not changing. Y square equal to z square. If you differentiate with respect to t, derivative of 500 is 0. So derivative of y square is 2y dy dt, 2z dz dt. Y and z are only two variables changing. So this is looks relatively easy questions. 2 and 2 got cancelled. Now here is the one where we are substituting y is 500 feet. When y is 500 feet, you do not know z. We have no idea what the z is. We also know that x is 500 because that's a fixed distance. So y is 500. Dy dt is 140. Here. I do not know z, which we have to find out, and we are interested in dz dt. So to find the z, this is a right triangle where two sides are 500, 500. So this is, remember we have been always saying that the two sides are same. So the hypotenuse is square root 2 times 500. So let's substitute here. That number is square root 2 times 500 and solve for dz dt. Looks easy question. So 500 in the numerator, 140 in the numerator, square root 2 times 500, and that will be feet per minute. Sounds easy question, this one. So finding distance from the balloon, finding actual distance from the balloon is changing. This is not the distance but the rate of change of z. We are looking at the rate of change of z. Remember, you are allowed to leave your answer like this. You don't have to simplify. It is open-ended question. Yeah, we love to cancel those 500s. So that's an easy way. But you don't have to. And if you are using calculator, make sure you are using correct, appropriate parentheses. So now I want to do the rate of the angle is changing. So that's what we did one in the class, but let's take a look at this question again. The rate at which the angle is changing. That angle is the here theta. Remember 500 is fixed here. We are still using the same information. 500 is fixed. So d theta dt. We are given dy dt. So let's check. We are given dy dt, which is 140, right? We had that number, 140. feet per minute. Now we could use dz dt, but we don't want to use that previous answer. So which equation is helpful here? Sine, cosine or tangent? So let's list on the side. Tangent theta is y over x. Sine theta is z over, no sorry, x over, sorry, what am I writing here? Hypotenuse. Oh, so y over z. Cosine theta is x over z. But we don't want to use the dz dt. We don't want to use this. So remember, x is a fixed. So this is our most helpful equation here to solve angle theta. So let's use this. Tangent theta is equal to y over x. Substitute x as a 500. So I can write it. Tangent theta is y over 500. X is a constant. Differentiate with respect to t. Derivative of tangent is secant square theta times d theta dt. Angle is changing. 1 over 500, you can write it as a coefficient. Derivative of y is dy dt. dy dt is given 140. Divide by 500. D theta dt, I do not know. Secant square theta. So let's find this secant square theta. Now back to the same triangle we are referring. This is 500. We also got the information that if I scroll it up, we have to use that piece of information here too. That when the balloon was 500 feet above the ground. So that means I have a given information y is also 500. That's the time we are checking. That's the instant we are checking the angle of theta when it's changing. So 500, 500, the two sides are same. The angle theta has to be 45. Agree? Pi over 4. So what is secant square pi over 4? Secant square pi over 4. So when two numbers are same, so remember tangent cosine pi over 4 is root 2 over 2 or 1 over root 2, whichever way. So secant square pi over 4, what would be that number? If you substitute that number, that will be number 2, because root 2, 1 over root 2. This will be much easier if you take this ratio. 1 over root 2 and secant square will be 2. So if I substitute that information here, I will have d theta dt is equal to 140 divided by 500, and that 2 goes in the denominator. So this will be 140 over 1000 radian per minute. The unit is radian per minute, because when the feet get cancelled, angle is always in calculus, we always measure angle in radian per minute. So this is the rate of change of angle with respect to t when the balloon is rising at, when it was 500 feet and when Mrs. Working was standing here. What's the angle? It is increasing. You can see that the angle is, the rate of change of angle is positive. So that means it's going up and up and up and up. I hope you enjoy this problem. I'll see you in the class. Thank you.